Today we're going to be looking at how to determine if ratios form a proportion using equivalent fractions. We have a couple of examples that we're going to work through together here, so let's get started. It's important to note that in order for ratios to form a proportion, they must be equivalent or equal ratios. And in order to determine if ratios form a proportion using equivalent fractions, we're going to be following the steps up top that we see highlighted in yellow. So jumping right into question number 1, we're being asked to determine if the ratios of 2 to 6 and 5 to 15 form a proportion. So the first thing we're going to do is down below, we're going to rewrite these ratios in fractional form. So first we have the ratio of 2 to 6, and then we have the ratio of 5 to 15. So now that we've rewritten these ratios in fractional form, we're ready to start following our steps up top that we see highlighted in yellow. And the first step is to find the least common multiple. And you might be wondering, well, what exactly am I finding the least common multiple for? I have two terms, or I have a denominator and a numerator in these ratios. Well, we're going to be finding the least common multiple for our denominators or our bottom terms in these ratios. And in order for us to find the least common multiple, the first thing we're going to do is we're going to list some of the multiples of both 6 and 15 and find the least common multiple. So for some of the multiples of 6, well, we have 6, 12, 18, 24, 30, and 36. Now we're going to list some of the multiples of 15. So we have 15, 30, and hold up, we don't have to go any further here because we've already found a common multiple. 30 is a common multiple for both 6 and 15, and it also happens to be our least common multiple. So that means that down below, we're going to be renaming these ratios or fractions with the common multiple of 30. So we're just going to write these ratios out with a denominator of 30, or their bottom term has a value of 30. Now, just like when we're renaming fractions, we need to make sure that we keep these ratios equivalent by multiplying our numerator, or in this case, our top term, by the same value that we had to multiply our bottom term or our denominator by in order to get 30. Well, for the first ratio, we had to multiply our bottom term of 6 by 5 in order to get the multiple of 30. So we're going to do the same thing to our top term, which is 2 times 5, which gives us 10 for the equivalent ratio of 10 to 30. Now we're going to do the same thing for our second ratio. We had to multiply our bottom term of 15 by 2 in order to get 30. So we're going to do the same thing to our top term or our numerator. So we're going to multiply 5 times 2, which we know gives us 10. So we have two fractions and they have an equal value. They both are 10 to 30. So that means that these ratios that we started out with of 2 to 6 and 5 to 15 do form a proportion. They are equal. And we can write this as 2 to 6 is equal to, it forms a proportion with 5 to 15. Now moving on to question number 2, where this time we're being asked to determine if the ratios 3 to 4 and 8 to 10 form a proportion. So remembering our first problem, the first step that we need to do here is we need to rewrite these ratios in fractional form. So our first ratio is 3 to 4, and our second ratio is 8 to 10. So now that we've rewritten these ratios in fractional form, we're ready to start working through our steps that are highlighted in yellow. So first, we're going to find the least common multiple for our bottom term. So we're going to list out some of the multiples of 4 to start out with. So we have 4, 8, 12, 16, 20, and 24. And now we're going to list some of the multiples of 10. So we have 10, 20, and hold up, we don't need to go any further here because we can see that 20 is a common multiple for both 4 and 10. So that means that down below, we're going to rewrite these ratios with a bottom term or a denominator of 20 because that's the least common multiple between our two bottom terms for these ratios. So now we need to make sure that we keep these ratios or fractions equivalent by making sure that we do the same thing up top that we did to the bottom. So for 4, we had to multiply 4 times 5 in order to get the bottom number or the bottom term of 20. So we need to do the same thing to our term up top. So we're going to be multiplying 3 times 5, which gives us 15 for the equivalent ratio of 15 to 20. And now for our second ratio, for our bottom term, we had to multiply 10 times 2 in order to get 20. So we're going to do the same thing to our top term as well. And when we multiply 8 times 2, we get 16 for the equivalent ratio of 16 to 20. And clearly here, these two ratios are not equal. So since they're not equal, that means that they do not form a proportion, which we can write as 3 to 4 is not equal to, it does not form a proportion with 8 to 10. So hopefully by now you understand how to determine if ratios form a proportion using equivalent fractions. Help make math less complicated by smashing those like and subscribe buttons. As always, enjoy today's math journey.